Hello everyone, welcome to this video. In this video, we shall be studying about cosets which partition the group into equivalent classes. So let's suppose we have this group G, right? Now for this group G, we can define some subgroup of this group G. Let's call that by H. Now using the subgroup, we can define different cosets for this subgroup, right? And we can have different cosets and they could be identical to each other, or these cosets they are disjoint to each other according to the second property that I have listed over here. And third, this property here tell us that different cosets would have the same number of elements within them, right? So the size of different cosets is the same. And the first property says the coset representative which by which you can construct the coset, so which is A in this case, would definitely be present in that particular coset AH, right? So now if all these three properties are there for cosets, we already know they are there. So what cosets are doing, that cosets are partitioning, are given group G into different classes, right? Each one would have different elements, and no one is having elements which are repeating themselves, correct? So suppose this is the case, and so we have either the classes are equal classes, or they are disjoint classes. So that means we do not have any intersection of such kind in anywhere. More of the time, all the partitions, they are equal to each other. So here I have listed down that these three properties, they guarantee that the left cosets of a subgroup of H in G, they partition the group G into blocks of equal size. So this is all we know here according to these properties. Moreover, what do we call them? The cosets of H, when they partition the group G, we call them those partitions as equivalence classes. Why? Because in this case we have an equivalence defined, right? You know what is an equivalence relation? We have two elements A and the element B. Now this A element also belongs to our group, the element B also belongs to our group G, right? Now A is related to B whenever their cosets are also equal to each other. So in this case we say it is transitive, it is reflexive, and it is symmetric. If all these three properties are there, then we have an equivalence relation. Reflexive means A is related to A, so that means AH is equal to AH, which is true. So we have the reflexive property with us. Next, about symmetry property, it tells us that if A is related to B, then B is also related to A. Now we are saying that A is related to B, it means AH is equal to BH, right? So if this is so, then BH is also equal to AH, so that means B is also related to A. And for the third property, which is transitive, what does it mean? It means that if A is related to B, B is related to C, this would imply A is also related to C. So the first property we are assuming A is related to B, so AH would be equal to BH, right? And B is related to C, it means B of H is also equal to C of H by our definition. So from here you can see AH is also equal to CH, correct? If that is so, that means A and C are also related to each other, hence our transitive property is also there. So therefore in this case it forms an equivalence class, because here we have equivalence relation which is defined just like this, correct? So therefore a partition that form equivalence classes of equal sizes. To understand the concept in more detail, let me give you an example. Remember in the previous video we have calculated all the distinct subgroups of the group G, where our group G was U32 and it consists of all these 16 elements within it. Now for these elements we have listed down the complete list of distinct cosets, and they were H, 3H, 5H, 7H, 17H, 19H, 21H, 23H. All of them have the size 2 that we have already seen. So the each one of them have the equal size. So this group U32 is now partitioned into such 8 partitions where all of them have equal sizes and all of them, they are disjoint to each other and none of them is equal to each other. So this is the partition, and this is how you can partition the given group by different cosets of a given subgroup. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.